good morning, good afternoon, good evening. Welcome to the live stream today. My name is Ryan. I'm a data scientist here at KX and super excited to be joined by Nick. Nick, you want to say hello?
Hey, everybody. Nick Ivory, Senior Technical Account Manager and Solutions Engineer with KX. Happy to be
Awesome.
talking about PyKX today.
Perfect. Yeah, we're super excited for the presentation. And, really one of the interesting things as far as scaling real-time and historical data goes is Python by itself, it's not super good at that. But we're going to talk about how we can make it easier to work with real-time data and historical data today. And Nick's going to walk you through all sorts of interesting topics, diving into that. And then at the end, we'll go through a couple of demos, including a demo that builds out an entire real-time and historical data architecture. So it should be lots of fun. A couple of things while people are joining. First of all, yes, this is being recorded, so it will be available on YouTube immediately after the session ends, so you can go ahead and rewatch your favorite parts and share it out with your colleagues. And then also, we do have a comment section here that's available to you, and we encourage you to ask your questions in the chat. We do our best to answer all the questions live, and if we can't, we'll get back to you after the session in the comments. A couple of resources I want to mention for all of you joining. So we have something called the KX Academy. And the KX Academy is a free resource where you can come in, sign up, and take different courses on the various softwares that we have at KX, including PyKX. So there's a really nice Intro to PyKX course available to you where you can go complete the course. It should only take you a couple hours. And then you take a quiz, and at the end, you'll actually get a certificate. So you can go ahead and share that out on LinkedIn or share it with your colleagues. And then the really cool part about it, though, is that with these, within the academy, there's a sandbox. So that means that you actually get to get hands-on with the technology. And we use the sandbox within the courses, but the sandbox is also available to you even if you're not taking a course. So if you want to go in and just play around, check out, some basic demos, understand how you can do this. And in fact, the demo that I'm giving later today will be using the sandbox. So it just goes to show it's easy to get spun up, and all your dependencies and installs are done for you. So good resource there. And then finally, the last thing I'll mention before we get started is we have a Slack channel. And I highly encourage you to join that Slack channel. It's free to join, and really it's quite an active community. We have all sorts of channels within that, including a PyKX channel where you can ask all your questions and stay updated with all the new updates that are coming. So I think with that, Nick, I will go ahead and hand it off to you to get to the fun stuff.
Awesome. Thanks, Ryan. So I wanted to thank everybody up front for coming out and joining us today, talking PyKX. As we jettison into the holiday season here, there's still a number of big product releases that we're getting out there, trying to do a bit of education around. And there's a lot of interesting features, enhancements in the products that are soon on their way as well. So we have quite a bit of content today to get through. I'm going to jump into the demo here. Got a couple of demos up front that I want to talk us through, but I want to do a bit of a level set with some slides because I think there's probably a variety of different audiences coming in. So we're going to do a bit of a level set just to start out here. Now, as Ryan points out, this is better when it's a bit of a dialogue. So put your comments, questions into the chat. We'll address them on the stream. We'll take a more myopic, open-ended Q&A at the end of the session. But as far as the agenda goes, we're going to show 3 demos today. The first one's going to be a bit more of a looser demo, a look behind the PyKX curtain, just talking about how you get up and running, how you go ahead and install those packages, running your first notebook, and how we build out those analytics using PyKX. So we're going to take a post-trade example. Then I'm going to show you how to build out a historical database, your HDB, using PyKX and an equities data set. And then finally, we'll look at, Ryan's going to walk us through building real-time streaming data services using PyKX and highlight some of the newest features of PyKX 3.0, which was just released a couple of weeks ago. So One last time, I'll say, pop any questions that you have into the chat, and we are off to the races. So, quick overview of KX for those of you not initiated. We've been a leader for 30 years, providing FSI institutions with world-class time series database solutions. Now, our technology at KX is responsible for the exchange of trillions of dollars across global markets every day, and we've made our bones on the strength of the KDB Plus time series database, which you can find in 39 of the top 40 US banks. Now, more recently, we become a leader powering generative AI applications in the vector database space. And you can learn more about that by watching the last LinkedIn Live session that we did on time series similarity search. Today, however, we're here today talking about PyKX. And PyKX is KX's Python first library for building KDB applications and unlocking the power of Q to a Python native audience. Now, what is PyKX, right? If you haven't heard us talking about it by the end of 2024, well, you're in for a gift this holiday season. Let me tell you, we just released PyKX version 3.0, which is building on the last 2 years of feature enhancements. As of right now, there's really no better time to get started. In so many words, PyKX allows you the ability to unlock the power and performance of Q for a number of different use cases, but this is across your KDB estate. And it's for a Pythonic developer audience. Now, it allows you to use the language features of Q where and when you develop applications. And it's pretty easily expressed in these three, tranches, these 3 bullet points here. If you're a Python user, you'll find this to be a very familiar syntax, but it offers huge performance boosts over traditional Pythonic tools. So we actually have an API that's built into the language that allows you to create Q data frames using a pandas-like syntax. It's a pandas, would-be pandas API, which allows you to run your workloads with 0 refactoring of your code. And so what you're really gaining is you're capturing the performance improvements of KDB in a Python-first environment. So that's the first bullet point. The second bullet point is that it is easier than ever to create and deploy KDB resources using a Python syntax. You're going to see a multitude of examples of this later on. But for a third bullet point, the big, I think the big difference between this and some of the other Pythonic tools that KX has released over the years is that PyKX unlocks the ability to run code or Python code where it's written. What this means is that you can both integrate Python within a Q process, but also the reverse, integrate your Q code within your Python environment. There are also a number of query interfaces that are available that you can use to retrieve your data, including our SQL interface. And what this offers is the ability to accelerate your time to deployment without, duplicating development efforts. So just, I think 1 or 2 more slides here.
Quick question for you. Just sorry to interrupt, Nick.
Get into it.
One of the questions that we often get is like, can we use PyKX with any platform? So Linux, Windows, Mac.
Absolutely, yeah. Anywhere that you run Python code. So yeah, exactly.
Okay.
Windows, Mac, Linux. You can, if you don't already have an existing KDB estate. Ryan, you brought up the KX Academy. One of the easiest ways to get started trialing it, playing around with it, is going in through the KX Academy, signing up, and then you're off to the races right there. So if you're interested in learning a little bit more, I would definitely point you off in that direction, just to start. But yeah, absolutely platform agnostic, very flexible.
Actually, we had one more comment. I think it's right in the same vein here. Embed Py or PyKX?
Embed Py or PyKX? Well, so it's an interesting question. I think what you have to sort of consider is that KX is developing PyKX and supporting this as the Python interface going forward. What it does is it expands your existing Python feature set with your KDB data. And as opposed to embed Py or PyQ, any of the other interfaces. It offers true interoperability between Q and Python code. Now, for instance, I think with embed Py, you could only run Python code from a Q process. You couldn't do the reverse. I'll talk a little bit more about some of these features, but I think it's good to keep in mind we don't have plans to replace embed Py, but I think it is confident that PyKX will be receiving the full enterprise support as our first-class Python interoperability solution going forward.
All right, awesome. Thanks, Nick. And hey, keep the questions coming. This is good. We want to keep it a discussion. So thanks for the question.
Yeah, awesome stuff. So I'm just going to talk about some of the main reasons why our customers are using PyKX and the sorts of improvements that they're seeing as well. So there's three broad angles that I want to talk about. And the first is acceleration and time to deployment. It's probably the biggest reason why our customers use PyKX. A customer testimonial I could point to, one of our partners, the largest hedge fund in Manhattan, they've seen faster execution of their complex event processing workflows, which talking about several orders of magnitude faster than using pandas. And with the recent release of PyKX version 3.0, it's only getting faster. So we've seen some speed improvements there. Now, I'll show some of the results in one of the demos, but we're talking about hundreds of times faster with a minuscule fraction of the memory consumption, the memory footprint. Some of these numbers are really staggering, but I won't spoil the fun there. So the first, of course. Now the second is democratization for all sorts of different developers, different audiences. Now at KX, we love Q, right? It's a rich feature set. It is supreme in performance. It's not going anywhere. But for a lot of developers, it's also a barrier to entry. You have a workforce that is millions of Python programmers strong. We want to put Python and Q in the hands. Essentially, you federate KDB performance for a Python developer audience and future-proof that sort of app development. And so that actually leads into the third pillar as well, which is future-proofing and modernization. So we're supporting a single Pythonic library that can run anywhere that a Python process runs, and it reduces the burden of forward-looking legacy application support, right? So it's true that Python continues to be the standard bearer in both data science, data engineering applications. What PyKX allows you to do is build freely across a vast community of enterprise software vendors and open source solutions. And we're seeing that with a number of our partnerships as well. So sort of, brisking along here, being mindful of our time. Last month, we released PyKX 3.0. And this is building on the last 2 years of product development. So we've seen a number of further performance enhancements over tools like pandas and polars. We've seen with the 3.0 update, CRUD enhancements for tabular operations, various other fixes and improvements. And we have the changelog, which at the end of the presentation, I'll throw in the chat so everybody can look at the full release notes. But there's two main features that I want to highlight here that are really important about this specific release. And the first is the Pythonic Query API. And this is a new feature, right? It allows you to query and interact with data tables using a Pythonic approach, as opposed to how you would previously using either Q or SQL. This broadly unlocks the ability for Python users to get started interacting with tables faster than ever. And it offers yet another method of interacting with your data sets. So that's the first main feature. The second here, and you'll see both of these in the demos here, but the second feature that we'll be highlighting is Python first streaming workflows. That's the demo that Ryan's going to show, but this is the ability to create high performance streaming applications by defining and deploying resources using a Pythonic syntax. So what we're seeing is the full actualization of our KDB Insights vision, which is creating robust streaming architectures for high throughput, low latency application requirements without writing a single line of Q code. So I'm going to show you what that looks like. But I guess we're at the demos here. So why don't we jump on in here? I'm going to show you 3 demos today. And there's going to be a couple of themes that we keep coming back to. The first is just how easy it is to get started with PyKX today. All you need is a license. I'll walk you through that. The second is that this PyKX interface is designed with KDB performance in mind. It's a shared memory space with Python objects, and it allows you to write jobs in Python for ease of use, ease of development, rapid deployment, and then instantly refactor your Python code for KDB performance without changing your existing code base. Now, the third point that I want to focus on here, and perhaps most importantly, this is super performant when you compare against traditional Pythonic tooling. And we're going to show you the land speed test, what that looks like. But we're seeing some pretty startling speed and memory efficiencies. So let's get into it. Oh, that comes next. Let's go back here. Don't want to spoil what's coming next. Okay, so I'm going to walk through. This is going to be kind of a speed run. There's a lot of content to get through. What I want to show you first here is setting up PyKX, give you a brief tour of the features, and then I'll show you a post-trade analytic example, give you a better idea of some of the performance metrics. So off the bat, for setup, getting installed is just about as easy as could be. What you first need to do is reach out to a member of the sales team to get your provision with a license. Once you have a license, you could be running in a matter of minutes. So that looks like a pip install of this PyKX library. It's as simple as pip install PyKX, and then importing into your environment. As I mentioned before, it's designed to run where you write your Python code. So I'm on a MacBook right here, and I have a running KDB instance here that I'm connecting to. I also remotely have a Linux instance that's running KDB Insights. I'm using that for another portion of the demo here. So this runs, and it supports multiple platforms, platform agnostic. You import the library, and then you're free to use that just as you see here. So that's all it takes to get started. Couldn't be more simple. And that, I think, is the first takeaway, how to get started. So the second takeaway is talking about interoperability between Q and Python. Now, what we can see here is because we have a shared memory space between Python and Q, it's super simple to refactor our existing Q code and implement our K objects in memory. So that's what we're seeing here. This allows us to work with both Q and KDB objects in Python using a Q syntax. And if we look here, we can also see that we're loading a TAC data set locally, and then loading that into a historical database or HDB into memory, and then using QSQL to query. We're selecting Apple quotes here and finding our most recent trading day after the opening bell of data, and then looking at that in a tabular format. This is all done using PyKX. It looks very similar to some of the other solutions that you've seen before, but what we're showing today, again, is strictly PyKX. Now, just the same, in here, we can write Python code, and we can call it from inside of a Q process so that we can reuse and reference existing Python code without having to refactor anything, and call Pythonic classes, operate on them accordingly. As well, this is something kind of fun when using Jupyter Notebooks, the Q magic command, which allows you to connect to a running Q kernel, whether it's specified remotely or locally on your machine, and then run Q code, which removes the need to refactor your Q workflow for a Jupyter environment. So that's, as you can see here, we've written Q code. We can run that by specifying the Q magic command. Now, I mentioned a moment ago that this is a shared memory space. So it offers zero copy conversion. Let me run that back because that's actually a pretty big feature here. The idea between zero copy conversion, it takes 8 microseconds to convert a K object array with 1,000,000 integers into a corresponding NumPy equivalent using PyKX. So you can imagine that if performance is a concern, this isn't a limiting factor in the decision to work across both paradigms. If you prefer to work in Python, you can use K objects, which can also support conversion back and forth between Python, NumPy, pandas, and PyArrow as objects, as shown here. And you can see what that looks like once they've been cast. So a couple of things sort of brisking along here. The PyKX library as well supports IPC, both synchronous and asynchronous execution of jobs that can be defined to run on a remote queue instance. This is super important when you're defining and building tick architectures, which can require many services running across different ports, and you have high availability requirements, and you need IPC between them. As well, we have support for ANSI SQL queries using the kx.q.sql method. This is part of the PyKX library. It allows you to write and run SQL jobs against an underlying KDB data table, and then democratize that KDB developer experience for non-Q developers. And then I showed a little bit of this before, but we can write select statements with QSQL and store the result back down as a K object. We also have the ability here to run this exec method, which returns, it's either a list or dictionary object, depending on how many columns you specify. But what it does is it allows for simple conversion back and forth to NumPy objects, and makes for easy indexing into tables and columns, effectively enabling your complex search queries. Now, a little bit further down here, you can use the LOC method, which is familiar to pandas users. We can use this to locate objects in a pandas data frame, and this is, of course, using PyKX with the pandas API. So use this to search and compute, average pricing for trades, and then convert that back to a dictionary. And you'll see that these are executing in millisecond speeds, or excuse me, yeah, millisecond speeds or better. So to show a brief demo of actually applying some of these features now, we're going to load a couple of functions into memory here, and then we're going to take a post-trade example. So we've talked about our first 2 bullet points, and now I'd like to address the final proof point and show a post-trade example, which is going to demonstrate performance of PyKX over our existing pandas workflow, and show sort of a land speed test of the 2 of those together. So taking this TCA example, right, the first thing that we want to do is read in our quotes, trades, and executions data, which we see here. We're pulling that into memory and displaying that in the table. And then we'll start by putting that CSV data into a pandas data frame. And now we're doing the same thing here, reading that data into PyKX tables, which are defined using the PyKX library. You can see that it's using this kx.q.read CSV method, and that stores it into our quotes data table. So we can also add some attributes here, which allow us to define a sort of breakout across different symbols and categorize that data so it's a little bit easier to graph later on. Now, what we're ultimately doing here for our post-trade use case is calculating slippage across different venues as a function of these trades, quotes, and executions data sets. Now, we can use a couple of functions here, like this kx.qdistinct method, which will count the number of ticker symbols represented in the data. And then we can understand a measure of transaction volume and volatility for the the 2 topmost traded symbols. That's Macquarie and Baker Hughes. And then take a subset of our ticker data, look at those 2 symbols. So we've defined some functions here. Again, as above, We use this to calculate volatility. We're going to do this both in PyKX and then again in pandas. In running through this example, what becomes manifest is just how simple it is to perform time series analysis using Q. Or I should say using a Q syntax in PyKX. It's designed to be terse, powerful, and expressive, but what can often be written in a single line of Q code with PyKX would take several using Python. So you can see just how performant and how terse that is, and I'll show you what that looks like. So we're, again, defining a couple more functions here, which are going to help us to define our spread. And I'm going to jump down here and get to the punchline. So we've calculated some of these measures. We're plotting them on the left-hand side of the screen. Down here, you can see that we have measures of volatility and our spread as calculated for Macquarie. And then on the right-hand side of the screen, we see our trading volume for Macquarie. And then again, we do the same thing for Baker Hughes, right? So that's what this looks like plotted. Now, back to what I was saying before about the land speed test here. Doing this sort of calculations, what are the sort of performance improvements that we were boasting about earlier? PyKX versus the pandas speed test. So in calculating this post-trade example, we ran an experiment where we wanted to calculate slippage and a number of other let's call them measures here, and store them down into a data frame where we could sort of look at them side by side, and then across different venues as well. This is less important, but we did this across separate venues, and we did this first in PyKX and then again in pandas. So we've defined these workloads using PyKX and calculating our merged values, which is an as of join. And then we're doing this same workload twice. So once we're capturing memory performance metrics, and then again with speed performance timing metrics. And the idea here being that there's a number of benefits that we see natively using PyKX. One of them is that we have access to this as of join, which provides the ability to do lightning fast as of a moment in time joins between multiple data sets. Here we're joining our quotes and executions table, broken out by symbol and as a function of timestamp. And this is something that is ultra performant in PyKX and super cumbersome when you have to do it in either SQL or Python. So we can do this across billions of data points in an instant, and then continue on to do some of our aggregations or calculations. We define a mid value, our price differential, our slippage, and then merge all these values together into a table. I'll show you what that looks like. Again, we're doing this capturing memory and then doing it again capturing the timing, and then we define that same workflow doing an as of merge in pandas, and defining our midpoint values, differential slippage, and then capturing that into a payload. Now, I'll skip to the results here. On speed alone, we could see that this is our execution time here. You could see that this is pretty startling, right? Our pandas job executed across 26 symbols with nearly 1 million quotes, 20,000 orders. It took approximately 2 seconds to complete here. And you can see as well that PyKX finished in approximately 22 milliseconds. What that really translates to is about an 85x performance increase using PyKX over pandas. And just the same, if we scroll down and we look at our memory consumption, our memory increment, we could see that broadly PyKX outperformed pandas with 12,000 times less memory than using pandas. So the results speak for themselves here. And we can look at this and say, that these are some pretty startling increases. And with the advent of PyKX 3.0, again, we're seeing even further performance increases than before. So let me take a quick pause here. We're going to pivot out of this first demo, and I'm going to show you how we use PyKX to build database services and simplify database administration and management. We'll move into the second demo here. Now, I'm going to try and do this live here, and I guess just another comment up front. This demo is available for you to recreate through the KX blog. So at the end of my session here, I will make sure to throw this link into the chat so you have that handy as well. But you can go in, spin up an environment in KX Academy and build all this out. You don't need to, import any data. It has all of the management, in the demo itself. So I would encourage you to go access that, and I'll put those resources in the chat at the end of the call. So look out for that. Now, the first thing, as far as building and managing databases that we want to do here is import our PyKX library as we did before. So we're going to go off to the races here. Now, I'll show you. This is actually an older artifact because PyKX 3.0 was just released. All of the beta features previously are now alpha features, are now implemented into the full product release. So we're not actually importing any beta features here. We're going to define a location on our operating system where we're going to have our historical database. So we're going to call that my database. So I'm going to run that. And then, as before, we're going to use PyKX here to generate an equities data set and store it into a table called dataset. So let's run that. You can see what that looks like, the output here. We're looking at pricing data. This is 100,000 rows of pricing data across 3 different symbols. It's stored into our table in memory. And then if we scroll down, what we want to do is we want to use PyKX to, now that we have this table saved in memory, we want to create a table called DB table here, partition it by date, and then insert that data set from memory down into our historical database. Then we can call that table directly. So that, and so what do we got here? We'll come back to that in a second, but okay, well, let me come back to that. So we're writing that down into memory. I'll show you, and that's just printing it here. I think I'll show you what that looks like in a second. So as well, what we can do is when we generate additional data and look to update that table with additional rows, additional symbols, we're going to create new data here and then write that down into a database partition. And then let me see if I can try and do that now. Okay, there we go. Right. So we've added data to the table, and now we can print the result here as well. So these methods, as you can see, are available through the database administration API. This is, available through PyKX 3.0. There's robust documentation available that will walk you through how to use each one of these examples. Sort of moving along here, we have this rename table method, which allows you to take our DB table and rename it as finance data. This rename column method, which now looks at our finance data table and renames our symbol column to ticker. So let's go do that. And I think I ran this right. Yeah, I should. I believe I did. Maybe. Yeah. Okay. Then just make sure that that's good there. It's because I already ran it. Okay, moving right along here. So there's a couple of other, methods in here that are important. So we'll take an example of a more memory-intensive editing task, and we want to perform an operation on a practice column. Let's say we're going to make a copy of this price column, call it price copy, so we could use that copy column method, and we want to create this so that we can perform a Lambda function inline, which will just take 2 times the original price here and store it down. So we can apply that Lambda function using db.apply function, and then typecast that as a real data type so that we can see the result here in our finance data. So now you can see we have our price copy column in here, which is approximately double the price here. And we've also renamed our symbol as ticker. And you can see the sort of cascading results therein. Now, a couple last examples here. We can take a look at the number of rows across partitions in a table by using the partition count method. And by running that, we have a table that is partitioned by date. it's broken down neatly to show us how many days and how many rows per day are stored in our data table, right? So here we only have a single partition in that finance data. But what we actually have is several days across partitions. So this is the third, January 3rd. We want to backfill those for the first and the second of 2020. So we can use this fill database method here and run this and fill in those additional, yeah, let's run that, and fill in those additional partitions. Now, what this looks like down at the HDB level, so we have this stored in our temp folder. You could see, our partition here for finance data and orders. You could see, our price columns as well as they reside on disk, and see that all these operations have taken and been completed successfully. So what I wanted to walk you through in showing some of these methods is how we use the Database Administration API to create and edit historical databases and do the sort of database service manipulation and editing inline using PyKX so that you can build out these sort of robust tick architectures. Now, I'm going to turn it over to Ryan in a second here. He's going to show us a real-time example for how you can create many such resources and use interprocess connections to communicate between services to create these robust tick architectures for both real-time and historical data, both on disk and in memory. So Ryan, how you feeling? You ready to take the mic?
Yeah, sounds good, and really appreciate you walking through us through all that good
Absolutely.
stuff there. So some of that stuff, and not all of it, but some of it is in the introduction course. So on the academy. So if you wanted to get hands-on, that's a great place to go. Check it out and try it in the sandbox. But yeah, so let me share my screen here, and we can go ahead and get started working on this PyKX streaming and historical database architecture. All right, so what we need to do first off is just do our imports. Of course, we are going to be using PyKX 3.0. And what we want to do is get our database. And so what I'm going to do is show you what this database looks like. And this is what we're going to be loading in to our historical database in the architecture that we are about to create. And this is what that database looks like right here. So you can see, you have date, time, and then we are looking at commodity pricing. So there's several million rows in here. And you can see there's different information like your closing price, your high, low, open, and as well as volume too. So that's what we're going to be working with as far as the data set. Now, I have a couple other cells in here, but this is stuff that Nick just went over. So we're going to get right into the streaming part. All right. So when we're generating this streaming and historical workflow, there's really three main things that we're going to be doing here. First thing we're going to do is consume commodity and currency data at a frequency of 1,000 hertz. And it's going to look like what you just saw. And that data is going to be loaded into the historical database. But then we are going to set off a process that will sort of recreate a live data stream that's going to be put into this architecture. And then secondly, what we're going to do is generate minutely open, high, low closing information from the live data that's coming in. So in other words, we're going to do some live analytics on that incoming data. And then finally, after we create this architecture, of course, users need to be able to access that. So we're going to create a gateway that will allow the user to come in and do some authentication, as well as get access to APIs to query both the real-time analytics as well as historical analytics. So this is what this architecture looks like here. And we can just walk through this really quick. You have your feed handler, and this is going to be publishing live data into the ticker plant. And the ticker plant, that's just responsible for logging the live data coming in, as well as publishing that to the subscribed real-time database. So every day, at the end of the day, this real-time database would publish all of its data to the historical database. So this is like the core of this architecture. But then we can do some additional things so we can have analytics on all this data. And the first thing that we'll do is create a chained ticker plant. And this ticker plant you can think of as almost a replica of the original ticker plant. And this does not do logging. In other words, this will have more processing power to be able to publish this live data to other subscribers that have analytical sub-processes on them. So for example, this real-time engine, this is going to have a PyKX analytics on it that will identify the volume of all the incoming live data, as well as the open, high, low, close data. And then finally, you'll also have some historical database analytics that we do here, finding the volume of all the data in our historical database. And then we create the gateway to allow our user to access both of these analytics. All right, so let's go ahead. We'll get started actually building this out. And the first thing we need to do is to define a schema, which tells us what the data looks like that's coming into our architecture. And we have a time, which is just our timestamps, the symbol, which is our commodity symbol, and then, of course, the price as well. And then we can kick off this basic architecture here, which will create a table called feed that is based on the schema that we just defined. We're going to be logging into the logging directory right here that we have defined. And then the database that in this database is what's being loaded into our historical database right now, which is the data I showed you just at the beginning of this session, will be started in the historical database. So at this point, we have now defined our ticker plant, our RDB, and our historical database. So really that's the core of this architecture. So what we see is that right now there's nothing that's being streamed into this architecture. So there's no data actually coming in. We have the data in the historical database, but there's no live data. So there would be no data within our real-time database. So what I'm going to do is kick off a process that will go ahead and start streaming data into our real-time database. And we can run that and we can see the data has started the stream right now. So right at this point, we have data streaming in through our ticker plant being published to our real-time database. And then at the end of the day, it would be published to the historical database. All right, the next thing we'll do is add that chained ticker plant. So this is where we will define basically a replica of the ticker plant. And what this allows us to do is have other subscribers that subscribe to this live data, in other words, to the chain ticker plant, which will then allow us to create some analytical APIs that are acting upon the live data. Okay, so now let's create those APIs and create those analytics. So the first thing we'll do is create a post processor that calculates that open, high, low, close data upon the live data. So here we're just using some Pythonic PyKX querying, kx.column price, min, and then that's our low. And then you do the same thing for high, open, and close, as well as volume. You can do some cool different manipulations, like xbar this down to 1, or in other words, we're going to present this as minutely data. And once we have this post processor defined, meaning we're taking this live data and we're manipulating it into this open, high, low, close, and volume data, we can also define different APIs. So the first API is this open, high, low, close API, which will just allow us to find the current open, high, low volume of the current live data that's going into the system. And then secondly, we'll create a volume API, which will calculate the total volume for a given symbol. And this is all on our live data. So we'll run that. And then we'll actually create and instantiate this real-time process. So what's happening here is we're subscribing it to that feed subscriber, which is coming from our real-time data. We're applying the post processor to it, or we're basically creating the open, high, low, close data from that live data. We know we need to import the PyKX library so we can run these APIs here. And then we will register these APIs with this real-time process. So as of right now, after running this cell, we have APIs available that will run analytics on our real-time data. So let's give this a try, see what happens here, and we can see that we are finding we are calling the open, high, low, close API on the gold USD commodity, and we can see that our volume is actually increasing over time. So we're checking the open, high, low, close, and volume on this live data, and we see that it's live and that volume's adding up over time. So we have the real time taken care of now. Let's check out how can we create some analytics on the historical database. So what we're going to do is create a very similar analytic on the historical data. And because it's historical, it means we're going to be looking further into the past. So if a user comes in and says, hey, I want to see the last 2 months of data, and I want to see the volume of all those months for a given symbol. What this query will do is identify the dates that those months include, and then query the historical database to find the total sum of the volume within those months. So this is the function right here that will find the total volume in the historical database. It then we will give it the historical database the correct library, which we need PyKX to run this functionality here, and then we just register that API. So we'll call it query API, and we will basically be using this function that we just created and register that to our historical database. So once we run this API is created so we can run this analytic against the historical database. So let's go back up to the architecture and just see what we've done so far. And at this point, we've created the entire architecture right here. And this is great, right? We can run these analytics, but we need a way for users to come in and actually test this out and run these APIs on their own. So we also need to create that gateway, which is what we're going to do right now. All right. So let's create the gateway, and we'll do a bit of basic authentication. So a user should have a username and a password. In this case, we're just using regex for a password with some numerics at the end, just to show you could do authentication with these gateways that we're going to create, or the gateway that we're going to create. And then we will create an API on this gateway. So what this API is doing is it's got access to both our real-time analytics and our historical analytics. So depending on what that user is coming in and asking for, it will either run the query API just on the real-time, if the user is looking for just the immediate real-time data. In other words, they're just saying 0 months, so the data that's happening right now. Or if they were asking for more months of data, then it would query both the historical and the real-time and then sum them together. So we would be finding the total volume across the historical and the real-time database. So that's the function there. And then we will go ahead and create this gateway. So you can see we are connecting this gateway to the real-time processor and the historical database. Both of these are have those analytics stored on them. We don't need PyKX for this function. This is just some basic Python here, but we do need regex for our authentication. So we will make sure that this gateway has access to the regex library. And then we just ensure that this API gets registered. The function that we just created right here is registered as API called trade volume. So we'll run this and get our gateway created. And then once the gateway is created, we can do a bit of testing and see how it works. So let's just try 0 months. So what we're going to do is we're pretending to be a user. We say our username and our password, and then we're going to query the trade volume table here on the gold USD commodity for 0 months. So we're asking for the real-time volume, which is just about 5,000 there. But let's say I'm interested in like the last 3 months. So we need to query now the real-time and the historical database. And we run this and we see we have, tens of millions of rows. So that is the architecture. And we just created that entire thing in a matter of about 10, 15 minutes or so. And the beauty of this really is that it's quite flexible in how you create this. And we did all this just on the KX sandbox here, which is available to you through the KX Academy. You can try it out for yourself. But really, you can create this in any way that you want. Say you wanted your ticker plant and your RDB on an edge device and then your historical database in the cloud. Something like that would be no problem to do with this architecture. So you want to create some other analytics, you could create more real-time processes that are subscribed to your ticker plant, or different historical database analytics that are subscribed to your historical database. So there's a ton of flexibility here. It's something that we're really excited about. And our hope is when you're working with Python and you want to integrate real-time streaming and analytics into your application, this should make it a lot easier to do that. So with that, the last thing we got to do is, of course, just shut down everything at the end to save on resources. And I believe that concludes my demo. So happy to see if there are any questions in the chat. Let's see, did anything come in?
And maybe while we're looking at questions, just do a quick recap of some of the things that we've seen here today, because I think that, Ryan, your demo really encapsulates just how easy it is to get started using PyKX today. Again, as we were talking about earlier, all you need is a license, getting started, and then just how performant that is without refactoring any of your code. And so it really is. It really is in the wave of the future here. So yeah, I mean, I don't see any additional questions in the chat, but I had put a couple of resources as well that I'd promised, the building and managing database blog and the latest PyKX feature updates. Ryan, I don't think you're seeing any questions either, right?
No, I haven't seen any come in. But if you are interested in asking questions, or you're asking this after watching it later, go ahead and join the Slack channel. We'll be happy to answer any questions there. Connect with both of us on LinkedIn. We're super happy to connect with you guys and have conversations about all of this fun stuff. Yeah, I mean, we're just really excited about PyKX 3.0. Oh, here we go. We got a question that just came in here. Put it on the screen. Does PyKX integrate well with the Delta control installation, or is it designed to replace it?
Great question. Ryan, unless you want to take this, I think the answer is that you can use PyKX pretty neatly with your underlying like HDB resources and whatnot. It's not designed necessarily to replace it, but as I was talking through before, like this is going to be the Python first best practice that we continue to develop and support going forward. So we're trying to pull the emphasis back towards PyKX, right?
Awesome. Okay. So yeah, like I was saying, if there's any other questions, feel free to join the Slack and ask. Put it in the YouTube comments. It'll be available on YouTube just after we end the stream here. Connect with us on LinkedIn and check out the Academy. You can do that whole demo I just showed in the sandbox without really doing any setup at all. So really cool resource for you all. And with that, I think that should conclude it. Nick, really appreciate your part of the presentation. Really interesting to see all the new things that PyKX 3.0 offers. And I hope you all found something interesting from this. And we really just appreciate you taking the time to join the session today. And looking forward to talking to you later on and seeing you at some sessions that are coming up. So with that, thanks everyone. Have a great rest of your day, and we'll see you soon.
Thanks, everybody.